Year 12s. This video is for learning intention 38 on sum, difference and product functions. So I've been a bit cheeky here with the title. I don't quite like the title sum, difference and product functions. I'm going to start with something. I'm going to do a bit of a subtitle if you like, and I'm going to call that addition of ordinates, and I'll explain what that means in a sec. So this is going to be part one on addition of ordinates. I'll do a few examples of this and then we'll move on to some difference in product functions. So part one will be addition of ordinates. What are ordinates? Ordinates are y values. So we're doing addition of y values or addition of ordinates. Well, what's that good for? Consider this example. Let's say I have an example that's asking me to sketch f of x equals 1 on x plus x squared. And let's say this is a tech-free question. So they're asking you to sketch this graph and it's tech-free. This is quite tricky because we don't recognize this style of graph. Where do we see the basic shape 1 on x plus x squared? We don't. But what we can do is we can use the addition of ordinates method, which is a kind of, if you like, it's an approximation method, and we can sketch this. So the way to do that is to go, well, I don't recognize this entire shape, but I do recognize this one here, and I know that that is a rectangular hyperbola, so I'm going to call that g of x. And I also recognize that that's our classic parabola. So I'm going to call that h of x. So if we recognize the two parts, maybe we can sketch this. Let's have a go at sketching the two parts. And maybe we can come up with a way to sketch the original graph, the original f of x. So I've got our ruler there, nice big axes as always, no puny axes, especially for addition of ordinates. If you're doing addition of ordinates, you need a lot of room. There we are, there are our axes, and I'm going to do it in the colors just to make it really clear so we know what's going on. So we have a rectangular hyperbola there. So I'm going to sketch that one in red just to make it super clear what's happening. There's our rectangular hyperbola. And we can't forget our asymptotes. Those are very important. Must have our asymptotes on our hyperbola. We can't touch them, but they're there, so we have our y equals 0 and x equals 0. Here, right. So we've got our rectangular hyperbola, and we need to sketch our parabola as well. So that's x squared, which will look something like this. Alright, I'm going to accept that for our x squared. So there's h of x, there's g of x, but remember we want f of x. How are we going to sketch f of x given the information we have here? Well, that's a bit tricky. What we need to do is use addition of ordinates or addition of y values. So you actually need to do this graphically. what you need to do is look at the y values of each curve and add them. So over here, let's look at this red line here. The y value's up there, and it's adding a little more. So the y value is going to be here. It's going to come around here, and then the y value is going to go up there like that. There we are. Whoops. So let's sketch that. So that's part of our curve f of x. You can see, because it's 1 on x plus x squared, you can see that you'd expect the curves to add like this. So you can see if I take this y value and I add that amount, so let's do it as lengths. So if I have this length here and I add that length, then I expect it to be this length. If I have this length here and this length here again, it should be about double that length up there. If I have this length here plus this length, I expect it to be somewhere up there. So you can see what's happening. We're adding the y values of each curve. I'm adding the y values here to the y values here, and I'm doing this by eye. I'm eyeballing this. Over here, let's do a bit of an eyeball. So here the y value is just slightly negative, so it's not going to have much of an impact there, so it's going to just kind of subtract it a bit. But as this gets more and more negative, and this gets closer to the x-axis as well, it's going to kind of go down here, and it's going to intersect there, and it's going to drop all the way down there. So you can see what's happening there. We're adding the y values. Here y is really positive, and we're just adding a negative, so we're chopping off a bit, so it's just a bit lower. Here is the point where y is positive, and it looks like y is negative about the same, so it's like the same length there and there roughly. So that's going to be our x-intercept. So in fact, it should be more like that, our curve. So you can see where the y value is positive here, and it's like the equal amount negative, you can see the x-intercept there, and then negative wins down here, and then the curve just gets more negative. Alright, well, how do we find that x-intercept there? We make y equals 0. Let's find the x-intercept. x-int y equals 0, 0 equals 1 on x plus x squared. Well, we can multiply everything by x, so that gives us 1 plus x cubed. X cubed equals minus 1. X equals the cubed root of minus 1, and there's only one cubed root of minus 1, and that's minus 1. So we have minus 1, 0 here. Hang on, maybe I'm missing something. Maybe there's a y-intercept here. I don't see why there shouldn't be. Let's find the y-intercept. Let's pretend that we think that there's a y-intercept. Y-intercept, make x equals 0. F of 0 equals 1 on 0 plus 0 squared. See that? We're dividing by 0. That's nonsense. There's no y-intercept. So what does that mean? It means that f of x retains the asymptote here. So f of x actually has an asymptote there. It's approaching an asymptote. So we can, I want to draw that a bit nicer. So let's put the asymptote in. Let's do it in black because it's our asymptote for f of x. Let's make it super clear that we know that there's an asymptote there. And the asymptote is at x equals 0. Alright, so the black is our curve f of x. Well, we don't just want to believe me. Let's check on the CAS machine, a CAS calculator. Let's see what the CAS has to say about it. It's always good to check your answer on CAS. Really good habit. Let's go down and I'm not going to bother making a document. Let's see, 1 on x, 1 divided by x plus x squared. There we are. There's our graph. You can see the curve going down like this, and you can see the curve slipping up like that there, and it's following the asymptote as well. They've done a better job there. You can see it hugs the y-axis a bit more. I haven't really represented that as much, but it is really addition of ordinates. It's really an eyeball method. Like you're forgiven for things like that, as long as you can show you understand what the shape will look like. You're pretty good there. So you can see we've found the x-intercept. We know there are no y-intercepts because of the asymptote, and we've sketched a pretty obscure graph using addition of ordinates, adding y values. There's no reason to stop there when we can do another example. Let's see, what do we want to sketch? So we're feeling really confident now. So let's sketch something a bit wackier. Let's sketch f of x equals 2 times the square root of x minus 5 plus, let's see, so that's 2 times the square root of x minus 5 plus, oh, I'm trying to think of something good. Let's do plus 5 there. 2 times the square root of x plus 5. I can't think of anything much trickier really. Let's do plus e to the x. Okay, how could we sketch this? Same sort of story. So we're going to call this function here g of x, and that's going to equal 2 times the square root of x plus 5, and I'm going to call this function here h of x, e to the x, and we can sketch both of those. Nice big axes, as always. No puny rubbish here. There's our x, there's our y. Alright, this video assumes you're really down with sketching graphs, our basic shapes. So if you're unsure about DRT and how to sketch this, and it doesn't pop out at you right away, you've got some revision to do. So I'm assuming you're completely down with sketching graphs. So looking at this, I can see, well, it's going to be shifted to the left 5 units. And it's a square root graph, so it's going to look something like that. And it has a y-intercept, so the y-intercept occurs when x equals 0. So that's at 2 root 5. So it's at 0, 2 root 5. I would usually do the working, but I really want to focus on addition of ordinates. So I'm assuming you have all that information already down, that you're really happy with it. And e to the x. Well, let's do our e to the x. Oh, I was going for the color-coded thing. I'm going to stick to it. I'll do the color-coded thing. Got to show some commitment here. Negative 5, 0, 0, 2 root 5. Okay. Now, e to the x, we have an asymptote at y equals 0. And we're going to do e to the x. That's going to shoot up like that. And we all know that point is 0, 1. Alright, this is a bit of a funny one. How do we sketch this? Well, we've got 0, 2, root 4. It's all positive here. So everything's positive, and you'll notice it's kind of funny because you'll get this weird characteristic where it starts out, it'll just follow the graph e to the x, and then it will bump up here. So because all you'll have before -5 is e to the x, so it will be e to the x. It'll follow this asymptote. So this part, I mean, for values less than -5, this part doesn't even exist. So really, it's going to be e to the x there, and then it's going to jump up here and get positive all of a sudden. So there's going to be a bit of a jump. But then it's going to curve off a bit because the square root's going to be curving down, but this is going to be shooting up, and then it's going to shoot up again. So let's have a go at this one. So it might look something like this. So it's going to follow e to the x, and it's going to jump up there. I'm going to do this again. I'm going to do this a bit smoother. I'll show you what I think it looks like. And it's going to do that, and then it's going to just shoot up like that. I'm going to try that again. There we are. It's going to look something like that. We're going to expect it to just bump up when the 2 root x plus 5 comes in, and then go down a bit, and then shoot up exponentially. So that's going to be our f of x. What's this y-intercept going to be? Well, the y-intercept occurs when x equals 0, so f of 0 is 2 root 5 plus 1. There we are. That is 0, comma, 2 root 5 plus 1. Let's see what Mr. Kaz calculator says. That's a funny shape. Alright, let's put this one in. These questions are really uncommon for methods, especially on non-calculator exams. It's pretty low priority. So I wouldn't worry about it too much. If you want to focus on sketching your basic graphs, if you're unsure about that, go back to your basic graphs. Make sure you can sketch those. Go back to your algebra. This is really, yeah, it's on the study design. Oh, what's happened here? I've got some glitch. Alright, let's try again. It's on the study design, but it's just not really on past exams. I haven't really seen it. I've seen it in multiple choice, but with multiple choice you've really got your Kaz there to help you. But it's on the study design, so we've got to make sure we cover it. Got to cover all bases. Alright, 2 times the come on, control the square root of x. Where did the square come from? Get rid of that. X plus 5. Whoops. Plus e to the x. E to the x. Let's see what we get. There we are. We get that funky shape. So you can see there the calculator's been a bit because here, so you've got your x plus 5, because here it's such a jump, it's hard to even see it on the calculator. So the value of e to the x here is so small compared to root x that it's not even included. But you can see that kind of characteristic shape, like you can see it do that curve. So it kind of goes down, it kind of decreases in gradient and then increases again. So I don't imagine it getting trickier than that. In the next video, this has been looking at sums here. So you've looked at addition of ordinates is sum and difference really. In the next video, we'll look at difference and product functions. And if you have been, thank you for watching.